What's up, everybody? It's Dan from SageMathTutoring.com, and I'm going to make a video about telescoping series, which is really any series that when you sort of add all the stuff, like 1 plus blah, 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 plus something else, plus something else, dot, 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 plus, let's say 100. Telescoping series is when you list all these, imagine these are numbers. But these sort of cancel, like all the middle stuff ends up canceling, and then you're just kind of left with stuff that was in the beginning and stuff that was in the end. Now, oftentimes you're just going to have, and therefore, of course, when you want to figure out what the sum is, you just add these two. You don't even have to worry about these. So I guess, you could think of a telescope where it's like you're peering through here and then you can immediately see this. It goes from here to there with sort of nothing in between. Okay. So it is the case that often problems are going to be such that there's only one term here in the beginning and then only one term here at the end. But every now and then you might have like a few terms here in the beginning, and then the stuff in the middle cancels, and then you're going to have a few terms in the end. So you do have to be kind of careful about how that's going to work out for you. So let's explore this one. This is a classic telescoping series right here, because when you imagine n is 1, well, that's going to be 1 over 1 minus 1/2, right? And that's what you get when n is equal to 1. Of course, we're going to be adding that to what you would get if n equaled 2, and that would be 1/2, minus 1/3, and that's what you get when n equals 2. So already you're probably getting a sense of what's going on here. If n was equal to 3, then it would be this. All right, that's what you get when n is equal to 3. Now you could imagine this continuing on. All right, so let's kind of bring it down here. Now let's investigate. We'll say a sub n minus 2. And that would be 1 over n minus 2 minus 1 over n minus 2 plus 1, which is n minus 1. And then if we were to then, add the next one, which would be a sub n minus 1, well, that would be 1 over n minus 1 minus 1 over n. And then finally, if we were to add that to the final thing of a sub n, well, that would be 1 over n minus 1 over n plus 1. Now, by the way, whenever you're doing this, just know that this last one, a sub n, that should actually match this. All right, so that's a nice mental note. Now, let's take a look at what's happening. I think you can kind of understand what's happening. So I think everyone can see that the 1/2s are going to cancel. The 1/3s are going to cancel. Actually, I'll use a different color for that. The 1/3s are going to cancel. The negative 1/4 is going to cancel with something else over here. Now, if we were to have the previous term, we would indeed see that the 1 over n minus 2s would cancel. We can immediately see here that the 1 over n minus 1s cancel, and of course we now have the fact that these 1 over n's cancel, so that sort of leaves us just with this first term, which is 1 over 1 minus 1 over n plus 1. Now, once you're there, it's actually pretty cool. You can set up a formula representing the sum. You could say the sum of this series, S sub n, it's going to be 1 over 1, also known as 1, minus 1 over n plus 1. So you can create that formula there. Now, what's great about creating this formula is now you can take the limit as n approaches infinity and actually figure this out now because we have infinity on the top. So in order to do that, you could let's just transfer sort of this situation over here. It's going to be the limit as n approaches infinity of 1 minus 1 over n plus 1, and that's going to end up being, well, it looks like it's going to end up being 1, right? Because it's going to be 1, really it's going to, I'll say it's equal to 1 minus 1 over infinity, and 1 over infinity is 0, so we're looking at this. All right, so that ends up being the answer to this particular kind of problem. Okay, so that's a telescoping series. So, feel free to pause, rewind the video, watch that over and over. But that's how you do it. Now, I'm going to give another example that's a little bit trickier, and then I think by the end of that, you're going to have pretty much the gist of it. Now, here's a problem where it might not look like a telescoping series because it's kind of like, it would be pretty messy if you think about it to, create that long chain here with a relatively complicated denominator. And it's also the case that there's no subtraction present here, so it's not like anything would cancel due to like addition and subtraction. So in this case, you would have to do partial fraction decomposition, and that would be a matter of factoring the bottom. Now that would be n plus 3 and n plus 1, of course. This 3 can sort of go on the outside, so I'm actually going to just erase that, and I'm going to put a 3 on the outside, and we have a 1 here. So the reality is that 1 over n plus 3 times n plus 1, if we did partial fraction decomposition, we could say that this is true, right? And at that point, what you would do is you would multiply literally everything by the, we could say, least common denominator. So we have this, just going to hover it, n plus 3, n plus 1. These would all cancel, of course. The n plus 3s would cancel, and the n plus 1s would cancel. Next thing you know, you have 1 equals a times n plus 1 plus b times n plus 3. So what you could do is you could imagine, well, if n equaled -1, then when you substitute -1 into this, it's going to become a 0, so that's going to be good. So therefore, we would be dealing with the situation that 1 equals b times -1 plus 3 is 2. So b is clearly 1/2, right? So that would be true. And if we also imagined another scenario where n equaled -3, well, then we could say that we have 1 equals a times -2, right? -2 times a. And the b part would cancel, so a would be equal to -1/2. So therefore, we could rewrite this scenario as -1/2 over n plus 3 plus negative or positive 1/2, right, over n plus 1. Now, I'd like to rewrite this to sort of replicate the earlier problem where it's going to be something positive minus something. So what I'll do is I'm going to rewrite this situation. We have the 3 on the outside. And we have, let's see, it's going to be 1/2, n plus 1, 1/2 over n plus 1 minus 1/2 over n plus 3. So that's how that would work. And then we can kind of flesh this out a little bit and see what's going on. So if we were to expand that, we could say 1/2 over, if n was 1, that would be 2, minus 1/2 over If n was 1, that would be 4. So that's all what you get when n equals 1. Now we would be adding that to 1/2 over, if n was equal to 2 this time, then we would have 3 minus 1/2 over, in this case, it would be 5, right? That's what happens when n equals 2. And then we would be adding to that what happens when n is equal to 3. So it would be 1/2 over, let's see, 3 plus 1 would be 4, minus 1/2 over 6, right? That's what happens when n is equal to 3. And it kind of goes on like that, right? So then let's just do one more to sort of make sure that we're really wrapping our heads around it. So we'd have 1/2 over, in this case, would be 5, minus 1/2 over 7. Now, some of you are already noticing, I'm sure, that stuff is going to cancel. So we have n equals 4 right here. Now let's investigate a sub, let's say, let's say n minus 4, okay? Now if that was the case, it would be 1/2 over n minus 4 plus 1, which is n minus 3. So how did I do that? I substituted n minus 4 in for n. So n minus 4 plus 1 would be n minus 3, okay? So then that's going to be minus 1/2 of, if we plugged in n minus 4 here, that would be n minus 4 plus 3, which is n minus 1. So then looking at what happens when we then investigate a sub n minus 3, let's just kind of get this over with. We're going to look at a sub n minus 2. We're going to look at a sub n minus 1. Let's just get this over with. And we're also going to finally look at a sub n. Now we already know what a sub n is going to be. A sub n is going to be the original structure. So looking at a sub n minus 3, that's going to be 1/2 over n minus 2. And this is going to be 1/2 over n. We would be adding, if it was a sub n minus 2, we're looking at 1/2 over n minus 1 minus 1/2 over n. Actually, not n, n plus 1 rather, pardon me, right? Now, let's just pause for a second. Let's make sure that we all agree on that. So if we're sort of substituting in n minus 2, well, n minus 2 substituted in here would be n minus 2 plus 1. That would give us n minus 1. N minus 2 substituted in here would be n minus 2 plus 3. And that would be the, n plus 1 part right here. So now we would be adding, let's see, we could also start to use a little bit of pattern recognition at this point, right? So we have 1/2 over, in this case, it would be n itself minus 1/2 over n plus 2. And then over here, we would have 1/2 over n plus 1 minus 1/2 over n plus 3. Isn't that fun? Okay. All right. So this checks out. I always like it when there's a method that allows you to know whether or not you're sort of on the right track. And this is a method because, again, this one should indeed match this one. Now, did we have to do this many? Maybe not, right? But I'm sort of choosing to be better safe than sorry. There's probably some way of knowing how many of these you need, but that's beyond the scope of this video. Better safe than sorry. We get the lay of the land of what's going on at the end. Let's begin to do some cancellations. These are going to cancel. right? Um, the 5 on the bottom, that's going to cancel with that. Okay. And then what you would see is that this next one would have been 1/2 over 6, right? And that, of course, would have canceled with that. So we'll use a green to represent that scenario. And then this would have been a 1/2 over 8, which would cancel with something, like later down the road. And I think everyone can see that this one would cancel with um, something down the road as well. Okay. So let's use yellow for that. We'll put a yellow over there. So we're only left with this part and this part, right? Of course, we could simplify that soon. Like that's 1/4 and that's 1/6. But let's investigate what's going on here. I'm going to work backwards. So the n+1 thing cancels with this one. The n+2 on the bottom, let's see, does that cancel with anything? It looks like it doesn't. The n on the bottom cancels with this one. This n-1 on the bottom cancels with that one. And what you would see is that this n-2, the leading term over here would have been over n-2. So this one would have canceled with something over there. So that would have canceled with something here. And this n-3 would have canceled with something way back as well. So I'm going to use green for that. Okay. So I think you can kind of see what's going on. We have a scenario where what's left over, I'll use purple for this. What's left over is this one, right? And this one, and this one, and this one. So we could go ahead and just create our formula here. So we know that S sub n is going to equal 1/4. I mean, that's this guy, right? Let's see. 1/4 looks like it's plus 1/6. And then it's going to be minus 1 over, let's say, 2n+4 minus 1 over 2n+6. Okay, so at that point, we can then, put in limit to infinity, right? So I'll say limit as n approaches infinity, and we'll put it over here too. Limit as n approaches infinity. So we're just going to do that. And I think you would recognize that these would all become a 0. So at the end of the day, we would indeed be dealing with, 1/4 plus 1/6, which happens to be definitely 10 over 24, which happens to equal 5 over 12. And that would be the answer to that one. Okay, that would be the answer to this. Oh, we have to multiply it by 3. Some of you may have caught that. So we have to multiply that by 3. So actually, it would be 15 over 12, aka 5 over 4. How about that? Glad I caught that. All right, so let me get rid of this. All right, so moral of the story, just be careful. Make sure you finish the problem. And anyway, that's how you would do a telescoping series problem that looks like that. So hopefully that makes sense to everybody. If you have any questions, let me know. If you see any mistakes, please let me know. But as per usual, even if I made a careless mistake, the process itself is definitely correct and sound. So hopefully that's helpful, and I will talk to you all later. Bye.